Hello, everybody. Welcome back. Robbie here with Lizzie today. She's with me today, Lizzie. Let's get going. We have a lot to cover today. Um, yes, sir. Today, guys, we're going to talk about the contactors, relays, and the EMF field. Okay, so contactors and relays and EMF. Next slide. Okay, so we have electric field. It's created by the voltage. When we have voltage present, live power, we have a field, but it's not the EMF yet. That's later. So we have voltage, but no flow. Remember, open circuit, no flow. So electrons going in a wire like this, they're just randomly going around in circles, waiting for a path. It's open circuit, electrons randomly moving around the atoms, waiting for a path. And we can test it by the non-contact volt. And most meters have it here. I have it on top right here. And then next slide is going to be the EMF. It's created by the electric current, the actual flow of electrons. So now we have a closed circuit, we have a path that create a magnetic field around the wire. Alrighty? And we can measure it. Now, another example is EMF is invisible energy field produced whenever electricity is generated or used. So when we have current. Okay, so EMF, we can measure it with the amp draw. This little thing here opens. My meter is broken, like last video I said. Okay, move on. When I was a student back a long time ago, 1994, 95, I think there was 95. My professor, Mr. Christopherson, he made an experiment. The one on the right side is plug in the wall, 120 volt applied, creates a magnetic field around the wire. You close it, you move the light bulbs close together. They're not touching, will cause one with spinning electrons. The magnetic field will cause the other one to spin, light comes on. Okay, EMF is very important in HVAC. We use it on sonar, on controls, solenoid valves, relays, contactors, transformers, and motors. Of course, very important in motors and compressors. And also down here, refrigeration solenoid valves open when EMF is, when voltage is applied, EMF is generated, opens. And also they're used also in air conditioning, some solenoid valves. Okay, let's move on. Contactors, we have triple pole, double pole, single pole. I'll explain that in a second, later. Contactors are normally open. And we have L1, L2, we call the line, coming in from the top, and it's black and red, as you can see. Power in, come out blue, because power is open, no voltage now. Power to load is out too, because it's open. Now, the other part is the coil. All right, power to the coil, the yellow and the white wires. Now power's off. And we have a spring. When the power is off, the contacts are open. Power is on now. We turn on the power to the coil. Contactor coil energized on, creates a magnetic field around the coil, causes the contacts to close. Boom. All right. This is very important because that's how compressor, you cannot run 220 volt in the house to switch the air conditioner compressor. All right. Thermostat calls for cool. Step one. Step two energizes the coil of the compressor contactor. Compressor contactor magnetic field closes the contacts. Okay. So one contactor energized on, two magnetic field, number three contacts closes and load on. Now the bottom picture here, see now it's open is blue. Now the wires turn to black and red because they have current going through it now. They are live voltage and current. Okay, let's move on. Then power's off and no magnetic field. Spring pushes back and it opens again. The spring will push it open. All righty. I hope you understand good about the contactor. This is view of both. Okay. So we have different kind of contactors. The one on the bottom, the white one here, have main contacts, auxiliary contacts. And don't get confused between contactors and three-phase starters. Starters have wires to measure the current between the phases. I'll cover that more in detail when we talk about three-phase motors. Now the contactors are rated in amp. I don't care what's the voltage going through. The amperage is wire sizes and contacts are measured through amp. The current, the flow of electrons. Okay, contactors are single pole. Single pole, that means one way in, one way out. Double pole, two-way in, one out each way. L1, L2, T1, T2. And we have three pole for three phase, L1, L2, L3, T1, T2, T3. Okay, sometimes we see even four pole, but that's very rare. All right, let's move on. Power is on top, L1, L2, power at the bottom, load at the bottom, T1, T2. They cannot use L1, it's already taken, so they use T1, T2 for the load. I think it should have been a D to load end with a D, but anyway. So, and here it tells you the rating, power in, power top. Okay, the rating is later. Okay, sorry. And the coil is 24 volt, 120 volt, 208, 240 volt, or 208, 240. And the coil, it shows the coil 24 volt, this one, 50, 60 hertz. 50 hertz in the rest of the world, 60 hertz in America will cover the frequency, different class. And this is both of them put together, coil and contacts. Alrighty, let's move on now. Another picture. And this one here, you can see in the unit, the contactor on the left, these are the capacitors. We'll cover that later when we talk about compressors. And the contactor here, this one, you can tell it's burned, the one at the bottom. You don't need to know, you can tell it's burnt. And this guy is replacing it with a double pole. I guess you can, but you have to be careful. Okay, contactors and coils. Now relays. We have single pole, single throw. Single pole, double throw. Double pole, single throw. Double pole, double throw. It's confusing, huh? Let me go back for a second. Okay, now let's go with this one first. So pole is power in, throw, how many ways you can throw out. In this case, one single pole, double throw. Quarterback can only throw to two receivers. So therefore, you can only throw to the normally closed receiver when there's no voltage energized to the coil, or you can do to the EMF field present, power energized to the coil, EMF field, you can throw to the now to the normally open. So either normally closed or normally open, you cannot have both ways. All right. Now let's go back to the double, 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 double. There we go. Single, double, one way in, two out for the single. Double, single, double in, single out for each pole. So that means one way out for each one. And now the double, double is two in, two out each. Double pole, double throw. Two throws per pole. And we have two poles. I hope it makes more sense, this one. Okay, the top section is one pole, normally open, normally closed. The bottom one is one pole, normally open, normally closed. And these are the diagrams. There's different ways doing the diagrams for them. Okay, let's move on. And that's all of them here together. Single pole, single throw, single pole, double throw, double pole, single throw, and double pole, double throw. I'm sure there's more, but these are the very common ones. Okay, let's move on. Like this one here, we have the glass ones also. And the glass ones are cool because if they're bad, you can just remove it and put one in. You don't have to replace the whole base and screw the wires in. Now this one here, the bottom view, you can tell. 2 and 7 is the coil. There we go. Coil going 2 and 7. And we have 4, 8, 3, 4, 3, 4, 5, 6, and A and B, it looks like. Yes, sir. So A to 4 is normally closed, A to 3 normally open, B to 5 normally closed, B to 6 normally open. That makes it a double pole, double throw. Two poles, A and B, two throw each. 3 and 4 goes to A, 5 and 6 is with B. B goes to 5 or 6, A goes to 3 and 4. This is a double pole, double throw. The voltage we don't know because we have to look at the back. We have to look at the name tag to know the voltage and the amperage. I'll cover that next. This is another example. This baby it says 12 volt here. It doesn't show. This looks like for a car, AC, yes. An AC car compressor clutch. This is also AC for compressor. It looks like 3 and let's see, it normally closed 3. This diagram doesn't belong to this diagram, 4 and 2. 1 and 3 is the coil. These are two different diagrams. The AC coil 2 and 4 is the coil. The one on the left is 1 and 3 is the coil. You have to learn how to read diagrams. Okay, normally open, normally closed type. Some are normally open, some normally closed. It's rare. All right, now, some diagrams are not actual. For example, here, number 5 don't exist. Number 5, there is no terminal block. See, but on the diagram it shows. Okay, let's move on. Later, I explain how. Now, single pole, single throw, this one, there's a name tag. And it shows here the voltage, 250 volt, 8 amp full load amp, 25 amp locks rated amp. We have full load amp and locks, full load amp, locked rated amp. That's how the compressor is rated, through both rating. I'll cover that more in details when we talk about compressors, the FLA and the LRA. Now, as you can see, between 2 and 4 is normally open. Two is here, four is here, and there are separated, there are space between them. They're normally open. And 1 and 3 is the coil. 1 and 3 is a little loop up. That means the coil. And there we go, together. This one is easy. 1 normally open. That's it. Single pole, single throw. Normally open. Easy, this one. Move on to the next one. Okay, power here, coil over here. Now, again, this one is 12 load, 12 amp at a 120 volt, 8 amp at 250 volt, 18 amp. RES, that's for heaters. There is no full load amp or locks roller amp. That's for heaters. And the coil is 24 volts. Okay, so now this is not number 3, even though it's not number 4, even though the 4 here, because 4 don't exist. It's jumped together, right? It's jumped right there. See, there's that metal jumper is that piece of wire right here. So number 4 don't exist. This whole thing is 6. So only 6, 5, and 2. There is the 5 and 6 closed. They're touching together, normally closed. And the 4 don't exist. So it's 6 and 2 exist. Okay, so you have to watch out. On the diagram, it shows number 4, but it's not 4. This is a 4, not a 3. 3 is down here. Okay, now this baby is, this looks like a double, single double. Yep, and let's look at the diagram. And it is single double. Look at that. Single pull, single throw. One way in, one way out. Single pull, single throw. Double pull, single throw. Now I'm confused. Double pull, 2 in and 1 out. This is a double pull, single throw. There we go. We got it. 1 and 3 is the coil. 2 and 4 is normally open. 5 and 6 normally closed. Okay, so this one, they did the same thing, except that jumper between the 4 and 6 is not there. They put a terminal block on number 4. It's the same relay. It's the same as the one on top. Okay, same one, except they just removed the jumper and added this one, and I made it one more pull in. Okay, now the double. The coil is at the bottom. It doesn't have numbers. On top, power in number 1 is out, 2, 3 normally open, 4 is normally closed. The other power, the other throw is 4 is in, 6 is normally open, 5 is normally closed. And when power is energized, it will switch. The open will close and the close will open. The one on the left is voltage applied, voltage 2, voltage applied. And as you can see, 1 and 3 is closed, 4 and 5 is closed, while 1 and 2 open, 4 and 5 open, switches. Okay, open, close. I hope this makes sense. When you power applies, it goes left side. No power goes on the right side. Okay, there is again power in here. Power in here, normally closed, normally open. Power at the bottom, normally closed, normally open. Okay, and the coil over here. And that's all 4 of them, 3 of them. The pole 1, pole 2, and the coil, right? Okay, let's move on to transformers. We have step up and step down transformers. In this business, we use a lot of, we don't use much step up, only step down. A lot of things are wrong on the internet. Picture here is wrong because the primary turns have exactly the same as the secondary turns. That's not transforming anything. The whole idea of a transformer is you have one coil, long coil, that's the primary, and the small coil is the secondary coil, should be small. Okay, because whichever turns you have on this side and the other, there's a formula. You have 1,000 turns over here and 500 turns here. The voltage will go from 1,000 volt to 500 volt. So it's 50-50. Okay, but a lot of things on the internet are wrong. This one have 1, 2, 3, 4, 5, 6, and 6. 6 on the primary, 6 on the secondary doesn't make sense. These pictures a little better. 1, 2, 3, 4, 5. 1, 2, 3. It's a step down. All right, so now what does all these numbers mean? Black to white, black, white, red, orange. So black to white, if the primary voltage is 120, we wire it black to white. If the primary voltage is 208, we will wire it to black and red. And if the voltage is 240, we'll wire it to black and orange. And the secondary is always 24 volt, and it's rated by 40 VA. VA is volt times amp, the 40 VA. So we know the voltage is 24 volt. So 40 voltage 24 multiplied by the amp of the amp of the control circuit. The amp, the secondary power of the transformer is using. Okay, and usually it should be 1.2, 1.4. So we can go as high as 1.6, and that will give us 40 VA. So this transformer will work. This is important to know, the transformer, because if you add more stuff, the customer wants more fans. Now you need to add more relays to control more fans. Then now the relay coils will consume more current. You're gonna need a bigger transformer already. My friend, I put for his house zoning. That means each room have its thermostat. The amperes will close and open. So every time a room energizes, if all the rooms energize cooling at the same time, all the coils gonna open, all the dampers gonna open and close. Then no more the VA will go up. Boom, the transformer will burn. So I had to go get him a bigger transformer, 60 VA transformer. Then I did the math, 60 backward now, 60 divided by 24, and now I know how much maximum current I can have. I hope this makes sense a little bit. The VA is the rating of the transformer, how much current it can use on the secondary, excuse me. Okay, and as you can see, this one, for example, 1,000 turn in the primary, voltage coming in 12 volt AC, 2,000 turn, step down to 1,000 turn, so now 12 volt AC. Okay, now transformers, the secondary, in this case, is red and green. The primary on top is common, is white. Always white is the common. One side of the power is white, or red, or black, or orange. Okay, that's white, black, white, red, or white, orange. And I'll explain next diagram. So if our supply of power to the unit is 120 volt, we got to connect the white and the 120. If the power to the unit is 208, we connect the white and the red. And we cap off these two. We do not connect together, or a cap. Wire go to nowhere. And if L1, 120 volt system, then white and black. Okay, and then for fun, we can do the resistance reading, and 64 ohms. This is the long part of the transformer. And this is the little shorter and little shorter. And the shorter you have, the less resistance. Okay, there we go. Okay, so the white to the, what was that? Black. The white to the black, 20 ohms. White to red, 52 ohm. White to orange, 64 ohm. Secondary is always 1.1 ohm in this case. Okay. This is a YouTube video. I'll post in the draft, in the chat. explains more about transformers. All right. Now, and we have the big transformers. I will cover this more during the power distribution. Alternating currents and power distribution. It's important to know how power is moved to the city. We're not electricians, but it's important to know the flow of electrons to help you diagnose systems. Okay, let's move on. Then next, I will do thermostats, controls, and reading schematic diagrams, the fun stuff. Very important to learn how to read schematic diagrams. You can fix anything as long as you know the sequence of operation. Sequence of operation, this term we use, that means step 1, step 2, step 3, do it by the number. Step 4, sequence of operation. First, I don't brush my teeth, then put toothbrush. Toothbrush first. No, first wet your toothbrush. Second, toothpaste. Third, brush, then rinse. Sequence of operation. We use that term a lot. Okay? Hopefully next video soon. Thank you. Anybody have questions? Leave in the draft. Peace. Stop sharing and peace out. Thank you and meeting.